Okay, it's on to Unit 4, Quadratic Equations, Functions. This is 4.1, okay? Unfortunately, it's a lot of graphing, okay? Graph each equation. These are examples. Y equals x to the second. That's your parent function. This is the... So you're going to make a simple table where you put values 2 through negative 2 in. Okay, and we're going to be making that table, starting with that every single time. But once you get the parent, you know what to write. 2 to the second is 4, 1 to the second is 1, 0 to the second 0. Negative 1 to the second is 1. It's not negative 1. If you square a negative, it ends up positive 4. It's in this number times itself. Okay, so 2, 4, 1, 1, 0, 0. You don't have to do the domain range. Didn't say so in the textbook, so we're not going to worry about it. There's your parent, okay? Now, this is similar to absolute value. Y equals negative x squared, okay? Now, the difference here is there's a negative 1 coefficient in front, so that's an a value. You make the same parent function of a quadratic equation on this assignment. Then a means you multiply all your y's by negative 1, all your outputs by negative 1, so negative 4, negative 1, 0, negative 1, negative 4. Then it inverts the parent function. A is you multiply the y, okay? Do you ever change the x? Yeah, but you do that with an h, not with an a. A's and k's change the y, h's change the x. Okay, so 2, 1, 2, 3, 4, 1, negative 1, 0, 0, negative 1, negative 1, 2, 1, 2, 3, 4. Okay, and there you have it. Okay, next one, y equals negative 1/3 x a second. Set up your parent table. 4, 1, 0, 1, 4. And then if you did 3 and negative 3, it'd be 9, negative 9 and 9, okay? I mean, if you did 4, 16, that's 60, it keep on going for infinity. That's an a value, the multiplier is an a, so you times all your outputs by negative 1/3. 4 times negative 1/3 is going to be negative 4/3, which is negative 1 1/3. 1 times negative 1/3 is negative 1/3. 0 times, that's 0. And then you're going to get negative 1/3 and negative 1 1/3. So I go 2, negative 1 1/3 is down 1 and then part of the way. Okay. Then I go 1, negative 1/3 is between the 0 and then 0, 0, and then it just goes around again. Okay, so the graph is compressed, so it's widened. And it's inverted because it was negative. Y equals 3x squared. You can bang these out pretty fast once you know your parent rules. 4, 1, 0, 1, 4. Because the parent function is y equals x to the second. Then you multiply them all by 3. Okay. So 12, 3, 0, 3, 12. We're going to go by 2's on the y, 1's on the x. So 2, 2, 4, 6, 8, 10, 12. 1, 2, 3, 0, 0. Then it comes back the other way. So the graph is narrower now because it has been stretched by a factor of 3. Y equals negative 4x squared. Again, that's an a value. 2, 1, 0, negative 1, negative 2, 4, 1, 0, 1, 4. Times them all by negative 4 then. So negative 16, negative 4, 0, negative 4, negative 16. Negative 16 is kind of extreme. Let's go by 2's again and 1's on the x. So 2, 2, 4, remember you're going down. 2, 4, 6, 8, 10, 12, 14, 16. 1, 2, 4, 0, 0. So it's been inverted, it's been narrowed, and from the parent function. Okay, now graph each function using translations from parent functions. It's the same concept, but now it's not an a value, okay? X, make a y there. I hate that f of x stuff, okay? Just find it useless. So 4, 1, 0, 1, 2. That's all, that 4, my bad. Now, this time the value we have is not multiplied by x squared. It's not an a. It's also not in parentheses with the x squared. It's a k value, okay? K values are to the y. You add 3 to all your y's. It means all your outputs increase by 3. So 7, 4, 3, then 1 plus, 4, 7. So 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And 7. Okay. Okay, next one. F of x equals x minus 2 to the second. Now this time it was just added to the x squared. Now it's in the parentheses. It's with the second power. That's now an h value. So a values we multiply the y. K values we add or subtract from the y. But h has to do with the x. Because it's this way. It adjusts the graph this way. We saw that from absolute values. So adjusting this way is moving on the x, not the y. So 4, 1, 0, 1, 4. But, so if you're doing it to the x, but you do the opposite of minus 2, okay? You add 2. 2 plus 2 is 4. 1 plus 2 is 3. 2, 1, 0. Now let's talk about this, okay? The reason we add 2, because look at this. 4 minus 2 is 2, and 2 to the second power is 4, okay? 3 minus 2 is 1, and then 1 to the second. You're trying to bring it back to the parent function. That's doing the opposite. Okay? So on the a and k you don't do the opposite, but the h you do, and it's to the x's. Now those are history now. So 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 0, 1, 1, 0, 4. Okay? Alright. F of x equals x to the second minus 2. K value. Okay. So the parent function of an y equals x squared is 2, 1, 0, negative 1, negative 2, 4, 1, 0, 1, 4. The parent function goes on to 3, 9, 4, 16, 5, 25, and all that. I just think 5 points is good enough. Okay, then a k value adjusts the y minus 2. So 2, negative 1, negative 2, negative 1, back to 2. Okay, so 2, 2, 1, negative 1, 0, negative 2, negative 1, negative 1, negative 2, 2. Okay, next one. F of x equals quantity x plus 5 to the second. That's an h value. Okay, k values a plus or minus outside the x squared. Inside the square, that's an h value. That means adjust the x's. So h's you do the opposite because you're trying to undo the plus 5. So minus 5. Negative 3, negative 4, negative 5, negative 6, negative 7. Now just check to see if that brings it back to 4. Negative 3 plus 5 is 2. 2 to the second power is 4. Perfect. Okay. So negative 3, 4. 1, 2, 3, 1, 2, 3, 4. You can also do this in your head too. I mean, 2 to the second power is 4. 4 minus 2 is 2. Okay? You can pick one of them and just do them in your head if you're good at that. 1, 2, 3, 4 up 1, 5, 0. Then we're going back the other way. Okay, nice. Then we get non-graph problems. Here's the directions. I need to write them for the virtual people. You have this notes up here, f of x equals a, and this looks just like the absolute value translations. HK is the vertex, but instead of a V, it's a U, okay? And then A is the stretch or compression. Here's what you got to do. You got to identify, you got 4 things you have to find, but they go quick. I've identified the vertex, the axis of symmetry, which is easy. The minimum or the maximum, it's one or the other. The vertex is the minimum or the maximum. You have to tell if it's a minimum or maximum. And the domain and range of each function. Okay, let's go get it. So y equals negative 1.5 parentheses x plus 20 to the second. That's an a, that's an h. Then outside the second power there is no k, so k would be 0. Okay, if you just want to briefly label it k and put plus 0, that's fine. Okay, vertex. That's your HK, but the H is its opposite. Opposite of plus 20 is negative 20. The K is 0. Okay. Okay, here's the axis of symmetry. Axis of sim. Okay. Axis of symmetry is always x equals, and it's whatever the H is, negative 20. Okay. I'll show you what, we'll see what how that looks when we get down here. I actually have to graph it. Okay, minimum or maximum. Here's how you do this. If your A is a negative, it's upside down. Well, that's a maximum because you only get lower. There is no minimum, okay? So maximum, just write the word. And the maximum is your vertex, okay? Just copy the vertex. Domain and range. Okay, domain, that's all real numbers, because if I made a line this way, it'd be on both sides, ARN. Okay, range, not quite the case. You put your y, and you put your 0. Remember, k is a y coordinate, 0. And if I made a line like this, you'd only be going down, so less than or equal. So if it's a maximum, it's less than or equal to 0, because 0 is the highest it ever gets. It only goes down from there. Okay, next one. Y equals 24x plus 5.5 to the second. So the vertex, that's your H, K. Okay, A, H, and then K is 0. It ain't 2, that's a second power. That's part of the function. So negative 5.5 is your H and 0. Axis of symmetry. X equals, it's whatever the H is, negative 5.5. Maximum, or no, don't put that, we don't know yet. Now A here is positive, that means the V is right, or the U, not a V, the U is right side up. Well, that's a minimum then. So basically if A is negative, you're going to have a maximum. If A is positive, it's going to be a minimum. And the minimum's the same darn point as the vertex. But you label it X, Y. Okay. I didn't do that here, but you know. Okay, domain. Domain's ARN. All real numbers. The range, you put Y. But from there, you just go up. So greater than or equal to 0. Okay. 0. 0. Okay. Okay, next one. Y equals negative. I'm going to put a 1 there, slap a 1 there. X minus 4 to the second minus 25. So I have an A, I have an H, and I have a K. Okay, H, opposite of minus 4 is 4. K is negative 25. The axis of symmetry. Okay. It's just X equals the H 4. Okay. Minimum or maximum? Well, we got to write which one it is first. A is negative, so if A is negative, it's like that. Then it's a maximum. That's a high point. Okay, so maximum equals whatever the vertex is, 4, negative 25. So now call that an XY. The vertex and the minimum or maximum are the same. Okay, they mean the same thing. So domain, range. Domain's ARN, because through that point, it's on both sides if I make a vertical line. But if I make a horizontal line, different story. Y, all points are below, because again, a maximum means it's less than or equal to, not 0, negative 25, okay, negative 25. Because see, that vertex is 4, negative 25, okay, so negative 25 now. Okay, then the last one. Just because it says f of x, that doesn't mean it's just a y, okay? So vertex is easy, okay? When it's written like this, there's another form that this can be written in where the vertex, you have to know a formula to find it. A, H, K, okay? So positive 5, negative 6 is the vertex. Okay, we also have to know the axis of symmetry, which is just x equals 5. Okay, minimum or maximum. Well, A is positive, so it goes down. Here's what might actually help you if you actually label your minimum or maximum. That's 5, negative 6, okay? That's your vertex, X, Y. Maybe put that. Well, that's a minimum. Now what's the coordinate? Well, 5, negative 6, same as the vertex. Okay, domain, range. Domain is x equals ARN. You can just put ARN if you want. Now the range, a different story. Because remember, it's all real numbers for x, because if I make a straight vertical line, it's going on both sides. But if I make a horizontal line, it's only above it. So greater than or equal negative 6, okay? I would recommend label, when you draw that picture, A is negative, so let's look like that. So negative 20, 0. So when you do your range, you know that Y is less than or equal to the 0, okay? Same here, I should have done negative 5.5, 0. So I know Y is greater than or equal to 0 because it only goes up. And that would be labeled 4, negative 25, same as the vertex. So Y less than or equal to negative 25. Okay, and I just about got this wrapped here. Okay, graph each function, identify the axis of symmetry. It goes quick, okay? Okay, write out your parent function, same as before. X, Y, don't mess with that f of x stuff. 2, 1, 0, negative 1, negative 2. F of x equals x minus 1 in parentheses to the second plus 2. Okay, and then 4, 1, 0, 1, 4. Now, there is no a value. A is 1, but we're not going to multiply by 1, so that's h, that's k. The h adjusts the x by the opposite operation. So I'm going to add 1 to all the x's, and the k adjusts the y. Add 2 to your y's. You don't do the opposite on the k. So 3, 2, 1, 0, negative 1. 6, 1 plus 2 is 3, 0 plus 2, 3, and 6. Okay, so 3, 6, 1, 2, 3, 4, 5, 6, 3, 1, 2, 3, 4, 5, 6, 2, 1, 2, 3, 1, 1, 2, 0, 3, 1, negative 6. Now you're like, what about the axis of symmetry? That's drawing a straight dash line vertical through the vertex, and here's how you label it. X equals, then you make your vertex coordinates 1, 2, and that goes straight through the 1. Okay, so x equals 1. Just splits it into equal halves. So label your vertex the 1, 2, x equals 1. Okay. Alright, f of x equals 2, absolute value x minus 2 to the second plus 5. So we got an a, an h, and a k this time. Okay, so 2, 1, 0, negative 1, negative 2, 4, 1, 0, 1, 4. Okay, now the a and the k are about the y, so a is times 2 first, then plus 5. Now the h adjusts the x by the opposite operation, so it's plus 2. So 4, 3, 2, 1, 0. 4 times 2 is 8, plus 5 is 13. 1 times 2 is 2, but plus 5 is 7. 0 times 2 is 0, but when I add 5, it's 5. 1 times 2 is 2, plus 5 is 7. 4 times 2 is 8, plus 5 is 13. Now you can briefly check that. 4 minus 2 is 2. 2 to the second is 4. 4 times 2 is 8. 8 plus 5, 13. So I did it right. I'll go by 2's on the y. I'll go by 1's on the x. So 1, 2, 3, 4, 2, 4, 6, 8, 10, 12, 13. 3, 7, 1, 2, 3, 2, 4, 6, 7. 2, 5, 1, 2, 2, 4, 5, and then it goes back the other way. 0, 13. Okay, axis of symmetry, label your vertex. It's 2, 5, the middle point. Makes sense, 2, 5, it's always HK. Go straight through that, and you write x equals 2. I've always found the axis of symmetry to be kind of pointless, but is what it is. Okay. F of x equals negative 3, x plus 7 to the second minus 8. Remember, a is negative this time, so it's going to be a upside down. Okay. So a, h, k. Parent function 4, 1, 0, 1, 4. Okay, so a and k, that's your y. So the a, we times the y outputs by negative 3, and then after that we would minus 8. It's got to be done times, minus. Now the h is inside with the x, so I go to x. The opposite of plus 7 is minus 7. So negative 5, 1 minus 7 is negative 6, and then negative 7, negative 8, negative 9. Okay, 4 times negative 3 is negative 12, but then I minus 8, and that's negative 20. 1 times negative 3 is negative 3, minus 8 is negative 11. 0 times negative 3 is 0, minus 8 is negative 8. 1 times negative 3 is negative 3, minus 8, negative 11, and then you're going to be back at negative 20. Okay? Let's go by 5's here, okay, and 1's here. So negative 5, negative 20. And also you can check to make sure it's right. Negative 5 plus 7 is 2. 2 to the second is 4. 4 times negative 3 is negative 12, but minus 8 is negative 20. So it matches perfectly. Okay, so 1, 2, 3, 4, 5, and then count by 5s. 5, 10, 15, 20. Negative 6, 5, 10. 7, 5, and then down here, then it goes back down. Okay, so it's upside down, just like I predicted. Now label your vertex, it's the middle point, -7, -8. H, K, or no, X, Y, my bad. So the axis of symmetry runs straight through there, and X would equal -7 all the way through there. Okay. Alright, last problem is a quick little application piece to a quadratic function. A gardener is putting a wire fence around the edge of his garden to keep animals from eating his plants. He has 20 meters of fence. What quadratic function represents the area of the garden? Now it's a rectangle. The area of a rectangle, which you should know, is the length times the width, but we need to write algebra expressions. Okay, he's got 20 meters of fence to put around the outside. Okay, 20 total. 20 meters total. And also I'm going to make a rectangle here. Draw that, okay? Length, width. Length, length, width, width. Length, length, width, width. Now we just need one length and one width to write the area. So what I need to do with this 20 is first cut it in half, because he's going to put the 20 meters, okay, around all the sides, okay, around all the sides. But we're only using two of the sides. So if I'm taking away an L and a W, I'm essentially cutting this in half, so it's 10, okay. Okay, because a garden goes around all four sides. Alright, the length we're going to call X. And I'm also going to put another thing here, okay? That means the length plus the width has to equal 10. Okay, I'm going to restart this problem. I'm bumbling through it like an idiot, okay? So draw an area, length, length, width, width. That's your start, okay? Now area equals length times width. Okay, so that means the L, the W, the L, the W add up to 20 meters. But I just want to take one L and one W and talk about that, okay? One L and one W and talk about that. So if I'm cutting it, I'm essentially cutting it and only looking at half the dimensions. So 20 meters are going to go on all four sides, but if I'm only accounting for 2 of the dimensions, I would need to divide it by 2, 10 meters. That means the length, one of the lengths plus one of the widths equals 10, okay? So here's how you write a quadratic function. First you call your A, turn that into a Y. The length you're going to call X, and remember, these add up to 10, okay? So if the length is 4, the width would be 6. If the length was 2, the width would be 8. If the length was 9, the width would be 1. Okay? So it's whatever the length is, I just subtract it from 10. So that would be X, and that would be 10 minus X. Okay? Then I want you to distribute X to 10, X times 10, and then X to -1X. So it's going to be 10x and -1x to the second, because -1 with 2 x's is x to the second. So -1x to the second plus 10x. So again, how did I get the 10? Well, I cut the area, I only need 2 of these, okay? So if L, W, W, L adds up to 20. If I take away an L and a W, then it's half of 20, which would be 10, okay? So I mean, on this problem here, 50 feet, that's all 4 sides. So if I cut out 2 of the sides, it'd go down to 25. So it'd be X and 25 minus X. Then distribute it out and get your